From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Good morning, class. Just to set the mood, because my name is Alex, and I'm here to take you on a trip down memory lane to a time where we've been all at school. Because I guess most of you probably, or who actually of you had a second language in school? Yeah, as I guess most of you had. For me, it was English, and I remember sitting in English class, and every time my teacher was using any kind of word I didn't know, I didn't understand, young Alex would just raise his hand and ask for the translation. But the teacher always would go like, who of you can explain that meaning to Alex, can rephrase it, can put it in a different context? And I always got really angry because I just wanted the direct translation. I wanted the German word for the English word to put it down in my vocabulary, to learn it by heart, to memorize it. And I could never understand why the teacher just wouldn't give the direct translation to me so I can memorize it. Funny enough, now some 25, 30 years later, the tables actually have turned. I find myself on the other side of that classroom now, being a teacher myself as a Red Hat instructor, doing consulting and stuff and teaching people now myself. And I suddenly understand why it's not about memorizing stuff, but about understanding stuff. So I always teach my students not to try to memorize stuff, because the more you memorize, the more you simply forget. It's about understanding core principles, to know how to use them, and to know how to help yourself, how to find possibilities to make your life easier, to find additional help. I had to learn this lesson the hard way. Being somewhat of a technical firefighter myself, finding myself in server rooms, somewhere in a bunker, in air-gapped environments, security environments, or even exam environments. So no Google, no Stack Overflow, and no nowadays ChatGPT or whatsoever. I simply had the tools that were at my bare hands there. And I always thought to myself, like, I'm on my own. Until I found out I'm actually not on my own. Because most of the times when you're sitting in front of a server, interacting with the Kubernetes clusters, you're probably lucky enough to sit in front of a Linux machine. And if you're sitting in front of a Linux machine, what do you actually have? Well, you have a shell, and in a shell, you have man pages. It's one of the biggest features, in my point of view, of Linux, that Linux actually explains to you how to use Linux. And don't worry, even if you don't know how to use man pages, there's a man page for man pages. So the only thing you probably have to remember is, to make your life easier, is man-k or man-K to easier search through those man pages. But in man pages, we have some usage informations. And if we want to use this usage information, we can actually not only look in man pages, but simply issue a command, a binary. For example, we use kubectl, kubecontrol, kubectl, whatever you want to call it. So if you use kubectl and you don't pass any commands to it, any further options, parameters, whatsoever, it tells you how to use it. Like, nice try, but I need more. So it actually tells you, like, there are basic commands, create, expose, whatever. And just in the middle of the screen, there is some command that really sticks out to me. It's explain. Well, kubectl can actually explain something to us, like show us documentation. OK, interesting enough. Let's find out what it does. So kubectl explain, issuing the command. Again, nice try, we need more information. There's a usage message. It's kind of hidden behind this error message here. It actually tells us there's a kubectl API-resources to give us a list of resources, because if I want to be explained some resource, I need to issue the resource. So, OK, let's try it out. So kubectl API-resources, and we get a list of all the cluster resources that are available to be explained by kubecontrol for us. Let's simply take an easier one. Let's take pods. So kubectl explain pods. And we get in information, there's a description. A pod is a collection of containers that can run on a host whatsoever. And there are some fields. So we have API version, we have specs, so specifications. Well, what are those specifications? I can even drill down. So kubectl explain pods.spec. And I get information about all the specification inside of a pod. And then I can even go further down. For example, containers. So pods.spec.containers, and I get information about all the specifications, all the possibilities, all the fields, all the parameters that are expected within a definition of a pod of a container inside of our Kubernetes cluster. However, this kubectl explanation is somewhat far away from this. So from a Kubernetes manifest, being it in YAML or JSON or whatsoever. So how do we get there? Because I want to declare it, I want to use it, I want to apply it to the cluster. There's one method I always teach my students, and I also apply when using a Kubernetes cluster myself. If I have to create any kind of resource, I simply look if this resource is already inside of the cluster. So I can use get, edit, apply. I look for pods, see there's a pod, the echo IP pod. Okay, let's get the echo IP pod, pipe it out in -o YAML, so output format to YAML, pipe it in a file, I got it. I edit it, here, just vim p.yaml, I edit it, modify it, customize, whatsoever, and then I simply reapply, so send it back to the kubectl, to the Kubernetes API, to the cluster. Besides the get, edit, apply, there's also a way to do it on the command line, a different structure. So even though Kubernetes is based on a whole declarative model, so everything is declared inside of the cluster by definitions, by manifests, we can actually use an imperative way of creating those declarative files. So you have kubectl create, and we just go ahead and use kubectl deployment, for example. And with kubectl deployment, we can create a deployment inside of the cluster. And now something really handy comes to us, because there is a button on our keyboard that is overlooked by so many people. I always see in my classrooms, it's a tab key. I don't want the people to write out like long JSON paths, commands, whatsoever. I see them like piping, copying, whatsoever. No, just hammer this tab command. I want this tab command to be replaced at the end of a year. So kubectl create tab deployment, okay, give it a name, echo IP, tab, and I see image. Yes, of course. The deployment has pods, has containers, container needs images, so I have to declare an image. Give it echo IP, beat 42, press tab again, and I get a list of all the possibilities I can use. So replicas, 42, for example. Okay, and now there is something else that's really important at this stage, or really handy for us. If we look at the usage information and the tab command, what all the parameters are that we can use, there is one we already seen, that is -o YAML, so changing the output format to YAML. And another one, that's dry run. Dry run meaning I don't want to send the payload to the Kubernetes API, but I want to have it generated locally. So I use -o YAML and -- dry run to actually create it locally. Don't send it to the cluster, just generate the file. Again, I'm just going to pipe it into the file, and then I can use kubectl apply, or put it in Git, use GitOps, Argo CD, whatever I want to use. So from imperative, I can go to declarative, and then to GitOps principles. And I end up with a file like that. I can modify, customize, whatever. So I don't have to remember like YAML indentation or whatsoever. No, I can simply press tab, give like a form, on the command line form I have to fill out, and it gets me all the information I need to create a file. If I'm lucky enough to have a Kubernetes distribution that actually has a graphical user interface, for example, OpenShift, I can even use the graphical user interface, the web console. Even though I'm a fan of terminal myself, the graphical user interface has become quite handy for me, because some tasks are just easier in the graphical user interface, or the combination of graphical user interface and terminal makes life just so much easier. So in the graphical user interface, I can also just go to my workloads, go to deployments, and fill out a form, or directly jump to the YAML form view and just have the YAML file. I can create it in the cluster, I can copy it, I can download it, modify, whatever. I just don't have to remember how to create those manifests. Another thing we have in OpenShift, for example, in the graphical user interface, is the API Explorer. The API Explorer is somewhat of a combination of kubectl explain and kubectl API-resources. So it gives you a list of all the API resources we have in the cluster, and also it gives you the explanations to those resources. And also it gives you all the instances being created on base of these definitions. Again, so in the graphical user interface, or it wouldn't be a tech talk at a technical IT conference if I wouldn't at least mention AI. So Red Hat OpenShift Lightspeed is something that's integrated into OpenShift. It's a local LLM that's based on the OpenShift documentation, so racked with the OpenShift documentation that you have in your graphical user interface. If you're not lucky enough to have this in the graphical user interface, you're not using OpenShift at all, don't worry. you can simply set up your local LLM, so Llama or whatever, and you can go ahead, download the Kubernetes documentation, OpenShift documentation, and just rack your local LLM to ask questions based on that documentation. You could even go one step ahead and use an interface, just script an interface that's talking to the Kubernetes API and ask about the current state in your cluster and also give answers based on the current state. If you don't have a way of interacting directly with the cluster, you could also simply do an extract, like kubectl get resources over all namespaces, so get all cluster resources, save them in a directory, all the YAML manifests, and put the YAML manifest directly next to your documentation of OpenShift, of Kubernetes, whatsoever, and then have your local LLM based on that rack, for example. I hope you enjoyed this little experience of mine, sharing those experiences I made. If you have any questions, feel free to ask them now, or come meet me at our DuxIT booth, just around the corner at K6. My name is Thomas Alexander Thomassen. I'm a principal architect and Red Hat consultant and instructor at DuxIT. And thank you very much.
From ContainerDays Hamburg, this video is proudly presented by DuxIT.